So for those of you who don't know me, I'm Mark Nelson. I'm also a venture partner like Ted here at Madrona, and also a recovering product and engineering operator. And so I'm here to introduce our panel. So for the last part of this, as we're at this moment of change, what we all like to do is hear what others are doing, because we're all figuring this out as we go along. So what we want to do is put together a panel of practitioners just like you and talk to them about what they're doing in this moment and how they're figuring out how their teams are going to run with GenAI. So we put together a great panel that includes a variety of devs, org sizes and shapes, I'll say. We've got Saju Pillai, who runs Kong Engineering. Woohoo! Big round of applause. So large existing code base, largely system, right? Like back end. We've got Munil Shah, woohoo! Our next contestant. From TalkTest, another large code base, but very user-facing, a lot of front end. And then we've got Raji Subramanian, who has the grace of being starting from scratch. So everything is born in this moment. And then we drafted Rob for double duty. And as he's already introduced, he's both a practitioner and trying to figure out how to build products for all of you. And they're going to have a great discussion about what are practitioners doing at this moment. So I'll leave it to you.
All right. Hello again. I feel like I should have changed shirts or something. Awesome. Well, this time, we're going to be okay on speaker. All right. I'm just going to kick it off and jump right in. I get to do the easy part this time, which is ask other people questions. And I will say, I was joking about not taking the spicy questions myself, but we wrote some questions down. I said to the folks on the panel, we won't get through these. I'll probably come up with something else that was on my mind today. If someone in the audience wants to just interrupt, if you want to throw your hand up and just get involved, we have the right size room for that. So have at it. All right, but to at least give you all a chance to introduce yourself a little bit, here is the quick summary that I would like from everyone. I didn't write down your name, but hopefully you prepared. Okay, name, company, stage, and size. I'll prompt you again if you get stuck along the way. General industry, problem space, and then on a scale of 0 to 5, 0 being absolutely no way, don't touch AI, 5 being you need a really, really good reason to not do everything with AI, where you were at in your company. All right?
All right. Hello, everyone. Saju again. Kong is what I would call a pre-IPO company. We just did our Series E. The engineering team is 200 in size, 210 to be precise. Total technical population there is probably touching 300 at this point. And I got stuck. What was the?
0 to 5. 0 is no way AI.
So maybe a little bit of context. Like Mark was mentioning, we deal with systems. I like to tell my engineering team our job is chasing infinite throughput at 0 latency. That's what we are trying to do. Our data plane, so we create event gateways, HTTP gateways, mesh, and so forth. And the control plane is a SaaS side of things, just to give you the context, because that will inform a lot of my position and the answers I'm going to give. From a scale and criticality perspective, we push out about roughly 2 times the monthly traffic that Netflix pushes out cumulatively across all of our data planes. We power a lot of critical traffic through the internet. So later on, I'm going to talk about very specialized situations where AI may or may not be able to help and so forth. On a scale of 0 to 5, assuming a linear scale, I'm going to say 2.
Engineers. All right, thank you.
Hi everybody, I'm Munil Shah. I lead product and engineering at a company called TalkTest. We are in the basically customer engagement automation in the contact center context. That's our space. And company is about 1,500 employees, 600 in product and engineering. We are pre-IPO, our last funding round was in 2021. So that's kind of where we are. Given the space we are in, we believe that whole customer experience is getting completely transformed, sorry to use that cliche word again, with AI and GenAI, which is why I joined this company about a year ago. And as a result, we have embraced AI across the board in terms of not just the software development lifecycle. Today we talked a lot about code gen, where we think about using AI tools all the way from doing product research, product definitions, prototyping, design, coding, testing, deploying, measurements, all of that. And then, of course, use our own product for talk desk on talk desk, so doing our own customer support, doing our own pre-sales, things like that, because we are a communication software, all channels, audio, video, digital channels. So it makes a lot of sense for us to use our own product. So in the scale of 0 to 5, I'd probably say we are closer to 5. Never claim we are at 5, but I would say that's where we are.
I'll give you a 4.5.
There you go.
I'm Raji. I was a public company CTO until about a year back. And so I made a transition to the other end of the spectrum. And so now I'm the CEO of a stealth startup that we started last year. So it's a wide range, and it's a wide transition that I kind of made. And I made it because of AI. We are in the fintech space. We're building quantitative models in finance and democratizing that for the retail consumer. So I'm sure all of you have portfolios. The portfolio sits at some point in the risk and return spectrum. More often than not, you're frustrated with it. And so what we use AI for and quantitative models is to decide where you want to be in the optimal spectrum of where you want to take your portfolio and build a path of how you take it from A to B. I know you gave a scale of 0 to 5. I would say we're absolutely in 5 and probably more than 5. Somewhere, between 5 to infinity.
Love it.
It looks like I'm the conservative option.
Yeah, apparently we sat in order. That's helpful. I love the redefinition of the scale. Nothing is simple on these panels.
We're
All right.
engineers.
Yeah, exactly. That's good. We like to solve problems and do new things. All right, I'm going to skip over the next one because you already answered it. Nobody knows that is on my page. I don't know why you need to know that. I'm just watching for hands. All right, AI adoption in your organization, top down or bottom up? Is it mandated, whether it's control or do it all the time, or is it grassroots?
It's not mandated. It's what we would call bottoms up or grassroots, with I'm going to say a very soft touch from the top. I'll explain. Maybe the framework that I use when I talk about this with my leaders is a good way to think about the current state of code generation through AI, at least from our perspective, is to think of AI right now as a SDE1 or a SDE2, if you may, right? And just with any junior engineer at that level, unless they can thoroughly understand the constraints of the system that you're operating in, you usually need a senior or a higher level person architecting the system, driving the LLM to get to the level of the quality and the all the other attributes of the code that it has generated. So with that framing in mind, a lot of our junior people, and I think someone was mentioning this, it starts with the juniors, but also some of our senior people are picking up some tooling by themselves. We don't mandate. We grease the wheels. The budget's available. You can just go ahead and pick up the tool of your choice, up to limitations apply, of course, and just play with it, experiment with it. There's a very strong criteria on what can go into production. And at this point, I'm requiring a human review, must happen, because of and that was, I was giving the background around all the throughput, latency, and all of those problems. It's a very constraint-heavy world. And a general purpose AI still cannot generate code of the type that we would want, just based on a simple prompt. Though that's what my product people tell me. They wish they could get to that place. But so that's what we do. Bottoms up with manual review mandatory for any code of that type.
Yeah, in our space, I would say it's both top down and bottom up, and let me kind of explain. So from the bottoms up, it's very similar to what Deepak said. We let 1,000 flowers bloom. We let people use a lot of different tools. Of course, when it comes to coding and the code that goes into production, we are more prescribed in terms of which tools you can use. But when it comes to RPMs, creating working prototypes, Figma creations, Figma to code, code to Figma, I don't even think about software lifecycle in the traditional way anymore because it's no longer a lifecycle. It's like you can go so many different ways. And we allow a lot of different tools. So there is a lot of bottom-up experiments happen. We have a channel, a channel where we encourage people to share their experiments. People share snippets of videos. Hey, here is what I tried. But there is a lot of top-down push, and that, like, I'm myself a big instigator on this, and I use a lot of different techniques in terms of pushing the message down. Of course, I share a lot of examples, kind of like what Deepak was saying, where you get an example, I will take that and I'll broadcast it, and I'll add my own perspective to it. But I've also taken a pretty strong position on this. Something like, I think I shared this recently on LinkedIn, and I've said this internally also. Like, I just think of my dev team in 3 buckets. I say, modern teams needs only 3 kinds of developers. There is either you are a God developer, meaning you can just write the most amazing code better than AI, and I only know a handful of God developers in the world. I was at Microsoft, I got to work with some amazing people. And then I said the second category is what I call supervisor developer, a developer who has a bunch of AI agents or AI tools, and then they just kind of let those tools do most of the work, and they are doing more of the higher level problem solving. And then there is a third category, which is everybody else. And I said, it's the responsibility of the third category developers is to prove that they belong to one or the two. And it's kind of a way of my way of saying that it's literally just first 2 category of developers who belong in the organization. And then I kind of say, if you're a manager, your job is to sort the engineers into these buckets. And if you can't sort them, then you probably yourself is in the third category. So you're kind of taking that strong position, kind of sends a subtle message to the org. But more than that, I'm more creating inspiration. It's not just me, but other leaders. But frankly, that's kind of how it started. But now it's very much a bottoms-up movement where people are just sharing their experiments, sharing their examples, and then everybody's piling on and saying, okay, you learned that. And Ted showed the slide with those tools. We pretty much use all of those tools in the team and more.
It sounds a little bit like you seeded, is that a verb? Seeded the situation, but now it's built enough momentum to keep going. All right, what about you?
Again, not surprisingly, it's both tops down and bottoms up. But there is a fundamental paradigm shift when we talk about tops down and bottoms up here. And the paradigm shift that I would kind of say is, to some extent, one of the diagrams you showed with software development lifecycle. I'd like to come back to that. But if you look at all of the value that we create as a company and break it down into the why, the what, and the how, we're talking a lot about the how today. Because, once it reaches the developer, how are you going to optimize that entire process? But when we talk about top-down and bottoms-up, it's not just about the how, it's also about the what. And it's a very, very important distinction, and I can give an example of that. And so when you kind of look at the how and the what in the software development lifecycle, you kind of talked about the code. It fundamentally goes down to how much code do you need to write? And a great example of how much code that you need to write is the entire chain that you look in terms of the interface that you need to create to access the code. I think when we were showing some examples, there are a couple of examples that kind of came through when you were showing the coding example to the question that I think the gentleman there asked, does it need to be readable? It does not need to be readable if humans are not reading it. But if you take that one step kind of further, and you think about all of the designs that you need to do when you're building an app, how many bells and whistles do you need to put in that app? Do you need to put all of those bells and whistles in that app? You don't. And so when we look at top-down and bottoms-up, it's not about reinventing this whole thing from a software development lifecycle. It's about reinventing it from a product development lifecycle. That's very different. It's about how do you actually change the what as well as the how. And one great example of that is, let's assume you have a portfolio and you're looking at your damn portfolio and saying, it's doing really great over the last 30 days, and the last 90 days. What would I have done differently? And if you want to play around with that, if I have to give you all of the knobs to be able to play around with it, it's going to take us a year to build. But if I put the quantitative model underlying that, and it takes in your portfolio and analyzes it, you don't need to build all of those UXs. The AI will actually build that UX. And so and this is something again, as a CTO of a large company, I kind of talked about this earlier. And again, as a startup founder, I'll kind of say the same thing. The question is, do we apply the filter as CTOs as enablers to value creation, or the people who are going to create value? Because not many people outside of this room know how the what is going to change, because they don't know what tools they have at their disposal to change the what. So it's a longer answer to the top down and bottoms up, but it's a top down, bottoms up with a paradigm shift.
Well, I love it, and I'm going to take your question instead of my question. What's up? Given that I can hear, I'm assuming everyone can hear, but I'll just repeat quickly. The question is effectively, how do you treat reward cycle, I guess, performance management, bonusing, whatever that is, based on the shift in how the expectations of developers?
I think there are certain things I'm already changing. So for example, we did this year's budget planning, and we're adding a set of headcount, and it's in the plan. But the way I'm allocating those headcount out is, I want the team to sort of prove it that they've actually embraced, or they've transformed the way they're operating, building the software, and only then I'm allocating the headcount. So it's becoming fairly known that if you're not going to transform, there is going to be a reward system is going to change, and I think it's become fairly clear that we are not going to have bucket 3 people in the organization, product or engineering, and so. It's more subtle right now. I don't know, we haven't taken any explicit action. But then you ask me about hiring. This is an active conversation that's happening in my team right now. It's like, how do we do the interviews? We know that, yes, you want to do in-person interviews because everybody can use these tools, otherwise a remote setting. But why not just give them the tools, during the interview and change the problems? Like, you don't ask some simple algorithmic questions. Maybe have a more of a complex project. Let them use the tools that they want to use, and see how they actually check for the proficiency of their ability to actually use the tools. So, that also is a change I've made in the organization, saying, I don't want to hire anybody who's not actually using these tools today, because maybe a year ago that might have been an exception. At this point, I just don't want to hire anybody like that.
So, go ahead, please.
No, please.
No, please.
Okay. So I would make this. I'd posit this claim that the kind of code that you can get a GenAI system to produce is positively correlated with the understanding of the system that the person that is actually prompting the AI. They're both positively correlated. The deeper and the more complex the problem, the more specialized the problem, I believe at this point, we are not in a place where you can go to a GenAI system and say, I want to create that very complicated XYZ, go figure it out. So I'm maybe just tying back into your question and to your answer. From my perspective, when we are interviewing, we are still selecting for that specialized understanding, that specialized mindset, that prior experience. And from a how much code can this person generate, or how much quality how productive perhaps this person can be. Yes, at some point when I'm ready, we can perform those mandates saying X and Y and Z of your code flow should now have an AI element in it. But I believe that at least for at least I'm going to constrain to myself now for Kong and for this kind of very specialized programming that is required, you probably are still quite some distance away from trading away the need for experience.
So I actually have a two-part answer to it. A very old-time Amazonian. So really, really old-time Amazonian. So working backwards is kind of tattooed in the blood. And so I think there is the two-part answer. The first part is, as any technologist, let's assume you're building a new platform today, and you're scratching it out and creating the next generation platform. As technologists, the first thing that we do is we'll say, what would the architecture look like? Where do we want to take this to? If this technology is going to last for, let's say, 7 years or 10 years or something, you architect the end stage vision, and then you build a glide path to that. In the same way, if you're thinking about what we're trying to do with the organization, I think as technology leaders, the first thing we need to do is we need to kind of define the vision of where the organization is going to be. Because then what you're doing is, then you need to make sure that you are engineering the organization to go to that direction. And so there's a glide path to that. So I think step one to the reward function, the way I look at it, would be to define what that revised organization is going to look like. And yes, there are broad strokes to it. You don't have all of the answers today, but that's also our job to kind of define and have a view on what that organization would look like. Because then you know who you need at that end stage. So that's one part. And then the second part is, if you, again, I sat through a lot of the Amazon performance cycles, and Amazon, I think it still does that today, but used to do a really good job of rewarding potential and rewarding performance. They're different things, because while you're creating the glide path, you need to balance both. So you reward performance for the now, but then once you know what the end stage is, you also have to evaluate who among your team will be in that end stage and who are the new members in the team that you need in that end stage. And so my guidance would be to come up with a reward structure that rewards performance. And we used to call it top tier. I'm sure it's called the same thing or some other manifestation of it, but you're rewarding potential. And so my guidance would be to define that end stage, then come up with a rubric to do both, and then take the glide path. But at the end of the day, through all of these, there's people involved, through the process. So it's our job to define that and then create the glide path, create the frameworks, and then guide the organization in the best way possible. Now, as a part of that, you also have the moral responsibility to say how much education I'm going to do within the organization.
So, it was a great segue to my next question, but I'm going to ask a question and then I'll come back to the audience. How are you measuring impact? Right, so we're kind of on not of the people, we just talked a lot about the people, but like a lot of us I think are on this maybe even blind faith mission that that everything will be faster and everything will be better and we need to be on this path, but are you, and if so, how are you measuring the impact as you transition tools and approaches?
Are we going
So the sequence? Okay. We're only doing partial measurement. For the obvious things, measuring is very easy, like speed to first prototype, that kind of stuff. Basic test case generation analysis, actually. There are some, looking at multiple signals, bringing them in, and then saying, okay, therefore we are saying so and so going to happen. So that's pretty easy. I think the real question here is, are we actually measuring and at an individual level engineering productivity? So I have a bias against measuring things like lines of code and PR raised and all of this. All of that is gameable. You can't send that to strong engineers and expect usually those kind of measures to survive, right? So, and maybe this is something that I hope to learn here. Productivity in terms of, okay, everyone, when we chat about GenAI, we're talking things will move faster, and people who are not particularly skilled in a particular language or not familiar with how a library works or so forth will be able to push through those blocks faster. That's generally what I hear, but from an actual measuring, saying your average time to PR has come down by this much, or your average review comments or so forth have come down, no, we don't measure yet.
Yeah, for us, I think it's just two simple metrics. One is the velocity, and velocity can be measured in different ways. But absolutely, I'm after the velocity. We are in a hyper-competitive space, and whether it's feature velocity, it's code velocity, it's idea to code, whatever way you want to measure it. But its velocity is definitely a metric I care deeply about and something I'm watching very closely. And then the second is what I call self-service. Our product, as I explained, is in the customer experience space. So when we use TalkDesk and TalkDesk, so all the support calls that come in, what percentage of those support calls are actually being handled by AI versus humans? When we do sales development SDR, what percentage of those inbound or outbound requests are handled by AI versus humans? So that's more internal implementation use of our product. But from the product and engineering perspective, it's all about velocity.
Yeah, I think the objective part is very similar to kind of what both Saju and Munil mentioned. There's the engineering velocity, and there's very clearly defined metrics that you can measure. But to your point, it's not lines of code. But there's also subjective ones, and the two subjective ones that again we kind of talk about product velocity, but what does that really mean? Product velocity is not just about the number of features you go ahead and get out there, but product velocity for me is about how many jobs to be done really hit the customer in the right way. There's a difference. To be able to do iteration and then figure out among the 10 different tests that you've done, which one works. So product velocity is one of them. And being a startup, you're always resource crunched. And so for us, how can you actually scale without actually adding resources to the ecosystem? So, orders of magnitude of scale that you can go the current team.
Yeah, and I believe, right, Raji, to your point, companies whose primary product has what I would call a MTTR focus, mean time to repair. If that goes down to 0, you can experiment, you can measure very rapidly. And there are companies and products that have mean time between failure is the top criteria. If you're pushing bits to the customer and the customer is running them, be careful with your experiments, right? Because MTBF is the high value. So that kind of changes the context and the answer and the approaches. I represent the MTBF field, I guess, here.
Yeah.
So
and the answer is different for different
yes,
ones,
exactly.
as you mentioned.
Wait, yeah, it was you that I shut down before. Yeah, go for it. Oh, sorry. Yeah, behind you in the black shirt. Yeah, right. Yeah, you. No. Yep. Yes, you. I don't know how to say.
100%. 100%. I would actually argue that even the decomposing the problem into the right pieces, that comes with experience, and that's an art. And it's not just about looking at a pure technical problem, but factoring in a bunch of other elements that goes into saying, okay, I'm going to decompose this problem exactly like this. And sure, you can take the individual pieces and get a code generation system to help you, more power to you, accelerate that. But then putting things back together, and this is where I will go back to what I was saying, that at least right now with wherever we are in GenAI, I do require senior and staff engineers to review and drive the architecture. I'll just make this observation, and I would love to kind of hear what people think. For complex problems, if how well you prompt the system is the thing that creates the code. And as the complexity of the problem climbs, won't the complexity of your prompting also climb? At some point, you are effectively writing code in English, which is a very weird language to write code in. I'm going to the limit here, but I'm just making the point that there is a curve, and at some point, there is what you're trying to solve and what you're able to express in the system. They start the return on that particular investment you're making just starts not being quite there. At least you need more senior people to do that at that point. That's what I'm saying.
Are you cool if I try to take more?
Yeah, go for it.
Because I feel like there's everyone has their hand up, and if we all try to answer all, hugging face. Yeah.
Impact is one thing. Over time, you see building a case to your organization. How do you do that?
I'm sure everyone has. I'm just going to repeat super quickly the fast version because I was a little quiet. But the question is effectively growing the skill set in junior engineers who then are sort of managing these tools because they're not, everything's moving so fast, you don't have time to sit and sort of apprentice. One of you two want to take it?
I'll give you a very concrete example. So, recently we had a production bug, and earlier we were talking about when the production bug happens, you do the postmortem, and the standard process goes. And as the engineer was writing up the document, I said, this is a code that was written 3 years ago, so not recent code, but we found a bug in there. And it was a try except block, and the block was inside a for loop, and the bug was in the exception block. And they were talking about. I said, hey, why don't we just ask AI, to do the code review for this, and then give us the suggestions and see what it says. And I said, try different tools. And this was a junior engineer who was doing the postmortem. And amazingly, of course, the AI found the bug because it's simple in the try except block. But what I found very interesting is that this is a code that was walking through all the accounts and and running a particular job. So if you're a more senior developer doing a postmortem or working with that junior developer, more likely it will find that particular bug fix. But more than that, we'll start talking about concurrency and performance and race conditions, and because it had all those aspects in that snippet of code. And amazingly, the AI actually, to my surprise, talked about all those aspects. And so in this case, the junior developer was literally learning the senior developer or a principal level developer skills from AI without having a senior or principal level developer sitting right next to that person. So I was very impressed with that. And so I actually think, of course, that doesn't eliminate the need to have more senior people in the organization. But suddenly you gain a senior developer that you didn't have in the organization that made available to this junior developer.
I just want to add one thing, because this is a very important question. I think the fundamental thing here is that I don't think the next generation of engineers are going to learn how to do impact the way we learned it. It's going to be different. And so the very clear difference is, again, many of us here had to spend ages, decades learning techniques and then apply analytical thinking and framework-driven thinking to drive impact. I think what many of the next generation of engineers are going to go through is they can literally leverage AI to do the techniques for them, which is very, very important, because when you're a junior engineer, I remember going through the service-oriented architecture at Amazon, you're learning a lot of the techniques, and it takes 80% of your time. And so you're going to spend the first decade learning techniques and then getting to the analytical thinking and framework-driven thinking. You can skip the decade. Again, there are long-term effects to that, but I'm just, at a broad stroke.
Yeah, I think that's a great point. Definitely, you're decreasing the amount of time to get to good. But I think a word you used really clicked for me. You said taste. And that I believe, and you could decompose that into three things. This is what taste probably means. But yes, an AI it's like a multiplier. If you're starting from very close to zero or a very small fraction, you're not going to move that much for sure. I think taste does need watching others do things, and that can be fairly automated to some degree, but you have to actually watch people that have absorbed decades of knowledge, somehow make it digestible for you and transmit it to you. For me, it's like, can you really send someone to the best school in the world, best teachers, etc., and they come out and are operating at a principal level? Maybe very, very few, but not in general, no. You would be very surprised if that happens. I think it's almost the same system here, in my mind.
Oh my goodness. Mm-hmm. Yeah, right here. Go for it.
So I'm curious, we've talked a lot about just raw coding and developer skills and just standard SDLC as it applies everywhere, more kind of general. But every business is different. Every business context is different. There's a lot of, when you think about principal and super senior developers who are still coding, they understand the business. They understand the customer taste. They know about isms, whatever they might be. Do you see kind of a world where there is just a general purpose kind of coding copilot, but there is kind of another agent that knows about all these things that maybe a blend of these two kind of, helps engineers solve problems kind of faster with more, high quality, high confidence. Any kind of experiments that you're seeing or that people are doing that, or do you see a world where general purpose tools will kind of just be the dominant thing that evolves this?
I just want to check again that folks can hear in the back. It's quite. Is it okay, or you want us to repeat questions back there? Repeat. Okay. That was a long question. Effectively, we're talking in very general terms about software development, software delivery lifecycle, but every organization has context, specific style, those sorts of, and a lot of the value in your more senior engineers is that they bring those things to the table as they're developing, and then they bring that to folks.
I can give the one-line answer to that. I think, because I'm sure Saju and Munil have responses to this. I think the fundamental question you're asking is the next JD going to be a software engineer or a product engineer? This is again why I keep going back to the what and the how. We're spending a lot of time on the how. The next co-pilot is not going to necessarily be about how do you make a software engineer succeed. I think the lines between a product manager and a software engineer is going to blur. And you'll be building co-pilots for the product engineer.
Yeah, I'll give an example. Just this week, one of the product managers who's been dying to build this specific feature, but has been waiting for the engineering team to become available, decided to say, you know what, I'm just gonna build this on my own. This is a developer who has not programmed, by the way, mind you, for 20 years. And he said, not only I want to learn programming, but I actually just want to see if I can build this feature. It's actually a pretty complex feature. It's called quality management in the context of contact center. Typically, you have a feature team working for months. And he went from researching the product idea to building a prototype, applying the Talkdesk design guide, and building an end-to-end working prototype, and then went to the customer and say, I want to get your feedback, all without talking to an engineering team. So my mind was blown that this is previously would not have possible until the engineering team created a space in their backlog and said, okay, we'll go build a prototype. So I think this is what I mean by the whole software development lifecycle is changing. We are talking about coding here all day long here, but it's not just about coding anymore. The way you research, we take our product and we verticalize it by industry. We used to deliver a new industry every year or so because it takes that much work to do in-depth work. We are on a path to create 10 more industries in the next 10 months. So it's just the acceleration of the feature development is gone up so much because of this rapid prototyping, using your existing context, and then rebuilding new features. I think earlier there was a question about complex versus simple, and I would say I don't quite think about problems that way. I think more in terms of brownfield coding or brownfield versus greenfield. That's where I see some differences in the way you approach the problem. Because the biggest problem is the context. If you have a very complex product, that context is very important for you to go and do an add-on features. And that's where the difficulty is. But otherwise, the rapid development tools are just pretty incredible right now.
I will say, I'll just go back. I'm trying not to speak too much, but you mentioned isms, you mentioned like style guides and things like I think one of the biggest shifts we're seeing in tooling right now, because it's really, that is very much in tooling, at least style guides, is that all that stuff is implemented in the tools.
Yes.
Right? So that you don't get the first pass that's like, hey, let me tell you how to do this properly. It's already kind of baked in. And then I do think, to Raji's point, like the product perspective ends up being the core of what the engineers
I think that's the point here. The isms are broader than the context of the code that was written. It's also where it must operate, what business problem it's solving, what are the do's and the don'ts, and this should be a very broad thing. And I think one of the tricks where I was saying the positive correlation between someone who's a senior or a principal or so forth and generating good code is they have that context that can selectively choose what to tell the, I mean, sure, you can say, you can load everything into LLM, and I think it's a worthwhile experiment if someone had a week free to do. Load all the context that, just dump a principal's brain into a into a LLM and see what it generates. I actually, we should do that and see what happens. But I think the ability to select that context and apply it to the problem, that is, I guess, a little bit of taste too. What applies and what does not, what you should know or not. I think that is key.
Yeah.
Hey, thanks a lot. So I had a question about product, and I think Raji and some of you guys have answered it. Maybe I'll ask the question, my other question, which is a lot of emphasis on coding, as was also observed, etc. What about building systems? Because a system, and particularly one that operates in the customer environment, needs to be deployable, needs to have diagnostics, needs to have performance and scalability and all of that. Have you touched or tried any of those aspects of software with AI?
Yeah, I would say my point of view is that the entire software development lifecycle is changing with AI. Of course, when you have a working production code that's globally distributed system, broadly deployed, that where you're trying to change, I'm seeing less of GenAI in the sort of traditional CI/CD space. Although we are creating Terraforms from using AI tools, code to Terraform, Terraform to code. I think all these things are happening in pockets. Most of the energy is in coding, but now I think I'm seeing that very rapidly shifting in the product management space. QA, of course, but when it comes to DevOps, CI/CD, then and then of course the lifecycle monitoring and things like that, there are experiments and there are small things happening here and there. But I don't know if there is a big transformative change. At least in my org, that hasn't happened yet.
Yeah, back in the back.
So, I mean, you guys have talked a lot about how this skill set is changing. I guess it feels to me like there's a couple pressures. Like, as a developer, like not your average developer is extremely good at writing bugs. And, from the interview perspective, like, I feel like a philosophy is that you kind of want to test for skills that are reflective of the job. So if you're not actually able to test for LLM uses in the traditional interview, like, do you guys experimented with strategies there to change hiring?
Yeah, that's what I was mentioning earlier, that we are changing that. So, I come from Microsoft. There are people here. We kind of follow, until recently, used to follow sort of more Microsoft style of interviewing. You do like 4 or 5. I'm talking about software developer. You do about 4 or 5 technical interviews. There is this, sort of a manager interview, things like that. But what we have moved to now is half and half. So there is half the interviews are still traditional interviews where you're, testing for core coding skills, and where you do pay attention to sort of how optimized code they write and their style and things like that, and standard memory space, memory and time trade-offs and things like that. But the other one is all about solve these higher level problems, use all the tools to your disposal, and see if you can actually solve higher level problems faster using the tool set, and basically get both the data points and then pick the candidate. So that's a subtle shift we made. I'm not sure if other companies have done this or not, but I mean, certainly we believe that this needs to be.
Yeah, I was just going to ask for you too. Are you in the, like, developers use whatever is on their laptop, like their toolkit, to do the interview, or do you sort of constrain what they're allowed to do?
Well, yes, constraint sorry, let me rephrase this. So all these interviews are over Zoom, so there's only so much constraints we can do. But yes, I mean, what we are testing for is, do you understand the domain? Can you explain the physics of this? And do you have some prior art, especially if you're a senior or a principal, you have a prior art that we can look at. And it's not about being able to discover something using, looking up something or being able to show us a piece of code that you have generated. You should be able to explain and reason about it. If you can explain the physics, our confidence level is high that, as GenAI, more of this stuff happens, you will be able to express those constraints back into the LLM and then get it to generate code.
Interesting. Okay, and you?
I can give the short answer because I know there are many more questions. If you look at the traditional interview cycle, if you leave the behavioral aside, you have coding, system design, problem solving. I think coding is going to become less relevant. Problem solving is going to take a much larger role. Critical thinking, analytical solving, I think companies are going to reframe how that part of the interview goes. Right now, that is the least codified part of the interview process, especially for an engineer. The coding round is very well templatized. You have a whole question bank within your organization. The second part is system design. You have a whole part of it that kind of goes in. But problem solving and analytical and critical thinking is the softest part. That's going to change. Today you do problem solving and the critical thinking, but typically it's kind of like, can you do this search better? And you're really looking at the algorithm. That is going to change. Critical thinking is going to change in terms of how you go. The type of questions you're going to ask is, it's not just about how do you do a binary search. You're really going to take, this is the value I want to create, how are you going to approach that value creation? And that's how problem solving is going to change.
But my takeaway based on the original question is, if you understand the problem space, we'll assume you can figure out the changing toolkit, versus we're going to watch you use the change toolkit and see if you're able to use that toolkit, which I think is a reasonable assessment.
Yeah. Also, just adding to that, I believe we are not at a place today, in especially with GenAI, where you can actually do a discriminated choice between the ability of two similarly well aware of physics people, their ability to express that back to the LLM. That's not the top constraint in terms of them able to use an LLM.
I think one thing I would say is that do in-person interviews. Strongly believe that all interviews should be done in person.
You may be talking to an AI on the other end, who knows?
All right, we have a few minutes left, so I'm going to go back to a couple of the things that we had talked about before. Thank you, everyone, for your questions and participation. Two things that I want to ask before the end, but don't worry, I'll give you the second question in a second. How do you keep your head amongst all the hype? Like, everyone out there has a self-serving perspective on what's going to happen, what's going to be useful. It might be your boss, it might be someone in the market trying to sell you something. How do you decide who's believable and where to get your information from about what's really happening? Other than obviously this group of people right here.
Bullshit detector.
Go ahead.
No, you're right. I mean, there's a fair degree of hype, and everyone, you periodically run into people who add the word AI to whatever they have been doing, and suddenly, value is very high. Understanding how, at some level, not an expert level, but some level, how GenAI actually works, how the LLMs work, how blah blah, you are able to. I'm sorry if I'll use the word again, but more loudly this time. If a bullshit detector triggers, you should be really careful. There is most of the claims that trigger the hype thing, they are usually 1-2 standard deviations above what everyone else is saying. It's not too hard for experienced people to sense that. I mean, the same caveat emptor you apply for other things is exactly what you should apply here.
Yeah, I would say that I think when people make statements, you've seen a lot of prominent people make statements that are like, hey, 5 years from now or 2 years from now, all coding jobs are gone, things like that. Like, I pretty much ignore those comments. It's simply because I'm not worried about what's going to happen 2 years from now. I'm mostly focused on what's happening today. And I think for today is, I want to let lots of experiments in the organization, let people try different things, and then make judgment based on that. I think I'm a very pragmatic person by nature, and so I like to see evidence. I make opinions based on what I see in front of me, as opposed to what somebody says, what's going to happen 5 years from now. So it's directionally maybe right, maybe wrong, who knows. I think we know, Deepak was also saying that, and I agree with him. Just 3 months ago, like, everybody was talking about Cursor, and then suddenly in the last 2 months, it's like suddenly a whole bunch of new tools and new things are happening. So these things are happening right in front of our eyes. So believe what you see in front of your eyes, as opposed to what's going to happen 2 years from now or 5 years from now.
I think it's kind of like two parts. There's a working backwards and a working forward. And again, we're all looking at where the puck is going, like 5 years, 3 years, 6, 7 years from now. And as you're looking at, again, this is for me, as I'm looking at figuring out where the puck is going and identifying that. It's kind of like more the thought leadership and that you're following. You want to go after deep thinkers who have done work in that space, really done work in that space for the longest period of time, and that longest period is when AI was being spelt as ML, and so that is one rubric that I apply when you want to look at where the puck is going. Then the question is, how do you work forwards? Because again, this is the experimentation that both of you were talking about. And I have only one rubric. Look at elbow grease and results.
Love it. All right, I'm going to try my luck. One sentence each for this last question. You've all been very informative. Now we're going to create the hype. All right. So let's talk future for 1 second. I mean, like you all, I advise everyone to ignore everything everyone is telling them about the future because no one knows. But what's something that's on the near-term horizon that you actually think, this has a chance of coming together that you're excited about in this space?
No,
Oh, you want me to go?
Yes.
I think AI is going to write most of the code, and it's also going to determine what we build. So it's not just going to be about the writing. For me, that's kind of like the rear view mirror. It's just a matter of time. So that's the difference.
I think the way we think about traditional software development lifecycle, and I'm not talking about just transforming the lifecycle. I just think we are going to think about the lifecycle very differently. It's a system that has many different entry points, and the entry points are going to be different. You might start from code, you might start from research, you might start from Figma. I think those entry points are going to be different, and then from that to where you traverse is going to be different as well. That's sort of, my last job at Microsoft was actually the team that built the developer tools. So when Ted talked about the last big transformation about Agile and CI/CD, like that's really, I get very excited talking about those things. And I think that it lives, but it probably just changes in a very different way. And the way we define software development lifecycle is changing. That's what I see.
I'll make a testable prediction. The org structure, engineering org structure with SDE is the pyramid. It's going to go. The base is going to go down over time. As time passes by, the width of that pyramid is going to shrink. Not the top, the middle layers also, but the entry layers.
Awesome. Well, thank you, all three of you, for participating, for engaging. And thanks again to everyone in the audience who had questions. They were way better than anything I came up with. So thanks for engaging. All right.